Okay, we're going to do both parts of problem 7 in one video. And so basically this is just going to be using the fact that the gradient vector is perpendicular to the level curves. Okay, so we're going to get two equations. We'll get two different representations for the tangent curve, for the tangent line. We're going to get the normal equation and the vector parameterization. So we'll do the normal equation first. This is the ax plus by equation. Okay, and remember, this is just ax plus by equals c, and the vector ab, this is perpendicular to the curve. And so since the gradient vector is perpendicular to the level curves, we can take this to be the gradient of f evaluated at 1, 2, because we know that the point 1, 2 is on the curve. Okay, and the gradient of f evaluated at 1, 2 is 1 minus 1. Okay, so if you plug it into the normal equation, we get x minus y is equal to c. And to figure out what c is, we plug in a point that's on the line. We know 1, 2 is on the line. So this is 1 minus 2 is equal to minus 1, and that's equal to c. And so the normal equation is x minus y is equal to minus 1. Okay, and now the vector parameterization, let me change colors. A vector parameterization. Remember, we need a point on the curve or a point on the line and a vector that is parallel to the line. Well, 1, 2, I think that's it. Yeah, 1, 2 is on the line. So that's 1, 2. And then a vector that is parallel to the line, it's just going to be any vector that is perpendicular to the gradient vector. So we could do minus 1, 1. And this is a vector parameterization of the line. Okay, let's go on to part 2. This is very similar. So we'll do the normal equation first. And again, if this was a test or something, I would tell you whether I wanted the normal equation or the vector parameterization. But since this is a review, I'm just going to do both since it's instructive. And again, I'm just going to write this form again. It's ax plus by is equal to c, where ab is any vector that is perpendicular to the line, perpendicular to the line, but we know that the gradient vector evaluated at 2, 2 is perpendicular to the line. Because remember, the gradient vector is perpendicular to the level curves. That means it's perpendicular to the tangents. This is 3, 4. Okay, and so this is 3x plus 4y is equal to c. And how do we figure out what c is? Well, we just plug in any point on the line. We know 2, 2 is on the line. So 3 times 2 plus 4 times 2. Let's see, this is 14. 6 plus 14. This is equal to c, and so the normal equation is 3x plus 4y is equal to 14. And now let's get the vector parameterization. So the parameterization is going to be L of t is equal to a point on the line, which is 2, 2, plus t times any vector that is parallel to the line. Well, we know that 4 minus 3 is perpendicular to the line, so this means minus 4, 3 is parallel. Okay, so this is how we do it. When we want to find, when we're given a curve in R2, and we want to find an equation, let's say either a parameterization or a normal equation, we find the gradient, and then depending on which type of equation we want, we just do ax plus by equals c, or if it's the parameterization, it's a point on the line plus t times any vector that is perpendicular to the gradient.